2, 1, welcome in. So an introduction just to a few items with respect to radioactive decay. So what is this radioactivity, okay, so that we want to be able to cover. So when you're going to get into nuclear reactions, and I do talk about nuclear reactions and give examples, so from alpha, beta, gamma kind of decays, I'll put up a link up above there. So that's not what I'm going to talk about here. This is just the introduction, maybe before you watch that particular video. So radioactivity. Now radioactivity with respect to these nuclear reactions, okay, that you're going to be learning about is basically the breakdown or the change of the nucleus of an atom. So the main key idea that you can think about is radioactivity, and you can kind of gap it towards, or at least map it to, the nucleus of the atom itself. And if there are any changes or breakdowns, then that we refer to as radioactivity that we have. Now, obviously, there's all kinds of different changes that you are going to be studying, but within the nucleus itself of the atom, any breakdowns or changes, okay, are this radioactivity that we discuss. Now, one of the key features of radioactivity is that it is spontaneous. Now, what does the word spontaneous mean? It means that there is actually no external trigger. It isn't caused by something else. It is just internally because of the instability, okay, of the actual maybe protons, too many neutrons, or something else is happening within the nucleus. So it's a spontaneous process of emission of particles or radiation from an unstable atom. And that unstable atom is the radioisotope. Now, if you want isotopes, okay, I'll put up a link up above there. Now, the goal is that the actual nucleus or the atom itself wants to achieve a more stable configuration, and hence this is why this process takes place. So it is the emission both of particles and radiation from an unstable atom, and that is the nuclear reaction that takes place, okay? And that was the first reference that I talked about, okay, or that I put up a link for. Now, what is the difference between radioactivity and, for example, nuclear fission? So this is kind of a nice and neat term. Now, one of the key items within and the distinguishing features is that nuclear fission is usually, and pretty much almost always, is an induced process of splitting a bigger nucleus into smaller nuclei. So it doesn't mean that that actual nucleus is unstable, right? Unlike radioactivity, where the instability causes that process because it wants to be much more stable. Nuclear fission is the induced. So we have an external trigger for this. It isn't necessarily caused by the actual atom itself. So it's caused and it's induced. So the word induced just means external trigger. And it is the process of splitting a bigger nucleus into smaller nuclei. And this is exactly, okay, what I have highlighted within here. So that is what nuclear fission is. And again, it is not necessarily unstable. It could be completely stable. Now, this process is accompanied by a huge amount of energy release because of the fact that we are actually splitting, okay, the nucleus into smaller items. Now, how does these two things, okay, so radioactivity, nuclear fission, okay, relate back to chemical reactions, which maybe you have been learning about in chemistry quite a bit? So nuclear reactions are not necessarily covered in chemistry. They are very much typically chunked into physics, although both are chemical related. Now, chemical reactions, when we talk about chemical reactions in chemistry, we have this idea and concept, and I am making the assumption that you've done a little bit about chemical reactions, right? So that's my assumption. And because physics and nuclear reactions kind of should be probably taught in either grade 11 or grade 12 or an introductory physics course. That means you should have had chemistry along the way before you've touched on, okay, the nuclear reaction process or radioactivity. So chemical reactions, you have reactants which combine, and yes, they produce products. Okay, so this is exactly what we see in here. So nothing extraordinary, and you've seen these reactions. Now, one of the key things, okay, within here, we'll jump to the item below there, is that there is actually no change in the nucleus of the atom. It just simply means that there's relocations that are happening within there. You know, so in terms of creation of bonds, changing of bonds, and so on. But the nucleus itself doesn't go through a change. If you want to talk about the nucleus itself changing, then that process, okay, is now into the nuclear reaction or the radioactivity that we have, or nuclear fission if we do it by an external trigger. So the total mass remains pretty much the same, and then you have this concept of balancing equations based on masses, right, where you talk about atomic masses, atomic numbers, and so on. Now, there are, of course, okay, like in radioactivity, because you may have, you know, an energy releases along the way, you still have this in chemical reactions as well, where you will have chemical reactions and it may be either, okay, kind of the release or the absorption of energy. Now, the release of energy, you may recall, is simply called exothermic reactions. And then the absorption is endothermic reactions. So you have these two. But again, the main key feature is that there is no change to the nucleus. That is the key feature. Because now as you jump over to nuclear reaction, this is now the process where the nucleus of an atom may indeed change. So these nuclear reactions, so there are various in terms of the decays that happen. So from alpha, beta, gamma. I do not talk about them here. Okay, that was the link that I provided. Okay, that was the second item, okay, within there. But within, okay, these, the key item between the chemical reaction and the nuclear reaction is it is the process where the nucleus of an atom indeed might change. So that is, we're going deeper into the nucleus and now what is happening there, okay, as we're going through. And now the other component is that indeed we're going to run into kind of new elements coming out. We don't necessarily have that in chemical reactions, right? We don't have new elements kind of within there. So that is nuclear reactions. So it's the nucleus that we're talking about and not the actual bonds and everything else that it's kind of between the various elements themselves, okay, in a chemical reaction. Now, there are two key ingredients or two features in terms of forces that you should understand as a student when you are going to be talking about nuclear reactions. Because these items, okay, so the forces itself, if you've been learning along, if you've gotten yourself up to nuclear reactions, then you've done a little bit of physics prior to this. You know, so where you have talked about dynamics and forces within, okay, except they're pretty much on an external component. Well, we have forces that are present within, both within the nucleus and within the whole atom itself. Now, one of the forces, which is a key force, is known as the electrostatic force. So this particular force is either attractive or it is repulsive. So it is a force which either attracts, okay, or repels. And now we know this, okay, and as you've kind of have been coming along, many students are not surprised that they are, when you have attractive forces and within there, so we call like forces that are charges that are two charges that are alike, like two electrons, okay, where they're alike, or two protons where they're alike. So they have the same charge, okay, where they either have an extra electron or one less electron, okay. So now within those, if they are alike, if you have two electrons, okay, then they're going to be repelling. And if they're unlike charges, they like to attract, okay, within. And these forces do exist. Okay, so this is what we have. And so like charges will repel and unlike charges will attract. Now, the electrons, okay, this is very interesting because it's a good question to ask. If we have these things, right, the electrons and you have the protons which are inside, why in the world aren't the electrons, if you have this electrostatic force, collapsing into the nucleus? Because the nucleus, which has the protons, which is positively charged, and then the electrons are negatively charged, so they should attract each other. Well, this is very interesting, and you should know this as a student, and you should kind of recall centripetal forces between. Now, if you have centripetal forces, which are objects, now this doesn't necessarily mean that it's just small little particles like electrons moving around their orbit, but even if you have enormous objects that are moving within an actual orbit, that means they have some certain amount of speed, so they're moving around. And then there's this concept of centripetal force. So that centripetal force does exist, right? But it's the movement that doesn't allow these things to actually collapse back in. So this is what happens. That electrostatic force is basically the centripetal force that is allowing these things to stay in orbit and not actually collapse back in. If they were not moving at all, if they were actually purely static, unmoving, then they would actually try to collapse back in, okay, from the orbit down onwards. So that's the reason why they don't collapse, because they are in motion around the actual nucleus themselves. The same reason why the Earth doesn't collapse into the sun, because of the law of gravity, which is our attractive forces, because we're moving around, okay, and we have a certain velocity. Now, in terms of jumping from electrostatic forces, which are kind of related back into like and unlike, so repelling and attracting, we also have to talk about these nuclear forces. Now, these nuclear forces are basically within the nucleus. This is what holds the nucleus together. So it's holding it completely together. Now, they're always attractive, right? So they're always attracted. They don't want to be repelling unless there's some instability that happens. And then we do have nuclear reactions, a change within, okay, the actual nucleus. And those nuclear reactions will take place. However, if you do have stability within it, these things will try to condense and try to keep these things together. Now, they are much, much stronger than the actual electrostatic forces, because this is also very common and a good question to ask. If you have the electrostatic forces, then you have protons that are stuck within the nucleus, but these electrostatic forces are not repelling them out. Why aren't they just completely shattering out of the nucleus? Well, the reason is because you have these nuclear forces that completely overpower within the nucleus the electrostatic force. So it is much, much greater than the electrostatic force, and that's why, although they are repelling, the protons are repelling against each other, the nuclear force, which is the attractive force, just keeps them in. The only thing is that that nuclear force acts on a very tiny distance within the nucleus. Beyond the nucleus, it just completely evaporates, and then the electrostatic forces take over. So it's very neat how nature is structured in this way. We have the nuclear forces within the nucleus just overpowering the electrostatic force. But once beyond, you go beyond there, it's the electrostatic force that are actually overpowering now, because the nuclear forces just kind of vanish. Okay, they're no longer there. They only act at a very tiny distance that we have. And this is what happens within here. So now, that is all that I wanted to present in this video. So I want to talk about nuclear forces and electrostatic forces and the difference between them. Okay, I wanted to talk about nuclear reactions and chemical reactions. What's the difference between those? Now I go much deeper into nuclear reactions and give various examples. So that's the link. I do encourage you to try to hit on that link. Okay, you can go back to the video originally and watch that next. And then I wanted to talk about radioactivity and the difference between nuclear fission that you have. Now, all of this is in the concept of radioactive decay. So that word decay basically means the spontaneous process of emission of particles and radiation. And that is the nuclear reactions that take place. Thank you for watching. I hope that you found this useful and an introduction to radioactivity. Okay, we'll see you in a future video. Bye, everybody.